All right, today we're going to be looking at section 4.2, which is angles of triangles. So we're going to be looking at triangles and looking at interior angles, exterior angles. What can we say about those? Which leads us to probably one of the most important theorems that we have in all of geometry. It will never go away. It will haunt you forever. So you should probably make sure that you know it really, really, really well. And that is the triangle angle sum theorem. What the triangle angle sum theorem that says the sum of the measures of the angles of a triangle and I'm going to do a little triangle symbol is 180. Okay, that's super, super important. No matter what kind of triangle it is, all the angles will always, always, always add up to 180 degrees. Now, if we want to write that as an equation, that would look like this. The measure of angle A plus the measure of angle B plus the measure of angle C, so all three angles in that triangle, equals 180. All right, so we know that in triangle ABC, A plus B plus C always has to be 180. This is only for angles. Don't get confused and do this for sides. The sides can add up to anything. All right, but the angles must always be 180. Now, let's just talk about really quickly why this has to be true. So I'm going to draw another random triangle down here. And I'm just going to label its angles 1, 2, and 3. Like that. We'll call that X, Y, and Z. And I'm not going to go into a formal proof with you. I just want you to kind of get an idea of why this has to work. So what I want to do is I want to draw a line that is parallel to XZ that goes through point Y. So here that's a line, we'll call it line L, and it is parallel to XZ. Alright, so I've got two parallel lines. Now, because I have those parallel lines, I know some things about the angles. For instance, angle 1 has to be congruent to this angle here, because they are alternate interior angles. So I could also call this angle 1. They're going to have the exact same measure. Likewise, angle 3 has to be congruent to this angle here because they are alternate interior angles. So this is also angle 3. So now if you look at that, I'm going to pick a different color to show this. This all forms one straight line, right? All three of those angles together form a straight line, so we know that they have to add to 180. So angle 1 plus angle 2 plus angle 3 equals 180 because they form a linear pair. Therefore, we know all the angles in a triangle add to 180. So that's kind of the explanation of why that's going to happen. No matter what the triangle is, you could draw parallel lines, you will always have alternate interior angles, and they will always add to 180. So now let's look at some examples of that. So looking at number 1, we want to find the measure of the missing angle in this triangle. So we're trying to find this angle here. We know the other two, we don't know that one. So I'm going to show you two ways that you can set this up, and you can pick out which one you feel more comfortable with. So the first way to do it is I can say that all of those angles add up to 180 degrees. So 65 plus 57 plus question mark has to equal 180 because of that triangle angle sum theorem. So therefore, we know that question mark has to equal 180 minus 65 plus 57. This is the other way we can set that up. So we can either add them all up, set it equal to 180, or we can say our missing angle is just going to be 180 minus the sum of the other two. So whichever way you are more comfortable with setting that up, I suggest you do. So now if we work this out, we find out that question mark is equal to 58 degrees. So our missing angle here was 58. And again, add them all up, set it equal to 180, or you can say that the question mark, the missing angle, is just 180 minus the other two. So let's look at number 2 here. We've got this 90-degree angle here, and we want to find, again, we want to find this question mark angle. So to do that, we know that question mark is going to be equal to 180 minus 90 plus 40. So that's equal to 180 minus 130, because 90 plus 40 is 130. So there, our missing angle has to be 50 degrees. Now, I want to stop for a minute. I want to point something out here. In a right triangle, something really special happens, in that one of the angles is always 90 degrees. So what that means is the other two angles are complementary to each other. The other two angles in a right triangle have to add up to 90. So another way to do this problem is I could have done question mark plus 40 equals 90. Because when you take 180 minus 90, you get 90. So the two small angles in that triangle have to add to 90 degrees. And again, you get the same answer. So you get question mark equals 50. And it kind of just saves you a step doing it that way. All right, so now let's look at number 3. So when we've got a big picture like this, and we've got several angles we have to find. So here we have to find 1, we have to find 3, and we have to find 2. So what I would do is I would break these into separate problems. I wouldn't try to do all of these things at once. And most of the time, not all the time, but most of the time you're going to be able to go in numerical order. So for instance, I can try to find the measure of angle 1 before I find the measure of any of the other two. And I'm going to replace that and write that in red. Before I find the measure of the other two angles. So for instance here, a way that I could find angle 1, well, I see that this angle here is 57. And so I know that 1 and 57 are supplementary. They make a straight line. So that means the measure of angle 1 is just going to be 180 minus 57. And when you do that, you find that the measure of angle 1 is 123 degrees. So now let's move on. Let's look at the measure of angle 2. So now if I look at the measure of angle 2, it's kind of included in this blue triangle here. I know the other two angles are 57 and 71. So that means that the measure of angle 2 will be 180, because that's what they all add up to, minus the sum of the other two. So minus 57 plus 71. And when you work that out, we find that the measure of angle 2 here is 52 degrees. All right, so the last one I have to look at here would be the measure of angle 3. So if we're looking at the measure of angle 3, again, it's in a triangle. It's in this pink one here. And we know the other two angles. So the measure of angle 3 will just be 180 minus 28 plus 123. And so when you work that out, you find that the measure of angle 3 there is 29. So the best way to tackle those types of problems is just to break it into 3 separate things. Don't try to look at it all at once or it'll really confuse you. All right, the next theorem we're going to kind of look at is the exterior angle theorem. Before we go into that, we kind of have to define what it means to be an exterior angle. So an exterior angle of a triangle is just an angle formed by one side of a triangle and the extension, so we extend it, we pull it out longer, make it longer, of another side. So for instance, if we were looking at this triangle over here, angle 1 would be an exterior angle. It is formed by this side of the triangle and the extension of this side. So because this side's extended, angle 1 there is an exterior angle. All right, the next word we're going to kind of define really quickly, and I'll do that in blue so you can kind of see the difference, is a remote interior angle. The remote interior angles are the angles that are not adjacent to the exterior angle. So the angles that are not adjacent to the exterior angle, whatever exterior angle you are looking at. So here in our picture, I'm going to do it in blue, our remote interior angles would be 2 and 3. Those are the remote interior angles. They do not touch angle 1. They are not adjacent with angle 1. So those are remote interior. So here that would be angle 2 and angle 3. And up here that would be angle 1. That's our exterior angle. All right, so now what we're going to do is we're going to learn the exterior angle theorem. I really didn't leave enough space for this. I wish I would have made a little more room, but I'll do it up here in the corner. What the exterior angle theorem tells us, and I'm going to write it out up here, is it tells us that the measure of the exterior angle, so here the measure of angle 1, is equal to the sum of the two remote interior angles. So here that would be equal to the measure of angle 2 plus the measure of angle 3. All right, so if we're going to write that in words, and I'll do that under it, the exterior angle is the sum of the two remote interior angles. So that is the exterior angle theorem. We can add up angle 2 and 3 here, and it's got to equal angle 1. And we'll talk about in class a little bit, because we're kind of running out of time tonight, why that happens, why that works. All right, so now let's look at some examples of that. So let's look at number 1. We have that this angle here is 71, this angle up here is 49, and we want to find the value of x. We want to find what does angle x have to equal. Well, we can identify angle x. Angle x is an exterior angle. So that means that it's going to be the sum of the two remote interior angles. And here, 71 and 49 are the remote interior. Therefore, x is going to be equal to 71 plus 49. Do you see why that works? That works because x is exterior and those were remote interior. So therefore, x has to be 120 degrees because it was the exterior angle. Now we have to be really careful with that, because if x is not the exterior, say it's one of the remote interior, we have to do something different. So now let's look at angle number 2. That example. We have that the exterior this time, we know what it is. We have it's 112. And we have that one of the remote interior angles is 30. And the other one is x. That's what we're trying to find. We want to know what that is. So again, since this is the exterior angle, you've got to identify it as that. We know that 112, that exterior angle, equals x plus 30. Okay, so 112 has to equal x plus 30 in that case, because we have that exterior angle. So be careful with that. So x, therefore, is 82. So our missing angle there is 82. And say that you accidentally added those together and you got that x was 42. 142. What you could do is look at that angle. Does that look like a 142 degree angle? No, it doesn't. It's acute. 142 is obtuse. So you would know that you messed up somewhere, and you could go back and then look at your mistake and see what you did wrong. All right, so we're going to skip that one. We'll look at that tomorrow. What I want you to do now is try these problems, see if you can figure them out, and when you unpause this video, I will have the answers up for you. All right, so here are the answers to those problems. Hopefully you did okay with them. On each one, I showed how to set them up as well. So look over those, bring them in class tomorrow. If you have any questions, we'll go over that then.